And now for the second part of our problem set. Given f of x is equal to 3x minus 5 and g of x is equal to x squared minus 2x, find. And the first thing we're asked to find is f of g of 3. So if we want to find f of g of 3, what's really important is to know the order of the functions that you're applying. So when it's written in parentheses form like this, the first thing we're going to find is g of 3. We're going to take that answer and we're going to plug it in to f. For me, I often like to do this by drawing pictures. So our function g is x squared minus 2x, and our function f is 3x minus 5. And so I think of, first of all, taking the number 3 and plugging it into g. And if we do that, that's going to be 3 squared minus 2 times 3, or in other words, 9 minus 6, out comes a 3. And what we're going to do is we're going to take that and we're going to put it into f. That's going to give us 3 times 3 minus 5, or in other words, 9 minus 5, or 4. And so our final answer would be 4. And so f of g of 3 would be equal to 4. We'll do the next one in a similar way, but this one's written with dots. So this is written g dot f of negative 2. When the composition is written with the dot, this is the first function that you do, the one closest to the number, followed by the second function. So this time, we're going to apply function f first, and then we're going to take function g and apply it to the result. So f is 3x minus 5, and g is x squared minus 2x. And the number we're starting with is negative 2. So we first put negative 2 into f. That gives us 3 times negative 2 minus 5, or in other words, negative 6 minus 5, and this is equal to negative 11. Now we're going to take negative 11 and we're going to put that into function g. That's going to be negative 11 squared minus 2 times negative 11. That would be equal to 121 plus 22, or in other words, that's going to be equal to 143. And so our answer for part B would be 143. All right, in the next one, this is not function composition. We know it's not function composition, although it looks similar, because it doesn't have a dot and it doesn't have parentheses. What this is asking us to do is f times g of 4. So in this problem, this is function multiplication. So in function multiplication, what we're going to do is we're going to find f of 4, we're going to find g of 4, and we're going to take our answers and we're going to multiply them together. So f of 4 would be 3 times 4 minus 5, or in other words, 12 minus 5, or 7. G of 4 would be 4 squared minus 2 times 4, or in other words, 16 minus 8, or 8. And what we're being asked to do here is multiply our answers together. So 7 times 8 would be 56. In part D, we're being asked to add our answers together, and what we're doing is we're inputting x. So if you input x into f, you simply get 3x minus 5. And if you input x into g, you get x squared minus 2x. And what we're being asked to do in this problem is add these two answers together. So if we add these together and gather our similar terms, we're going to have x squared plus 1x minus 5. And so this would be our answer for part D. Number 5. Given the graphs of f of x and h of x shown below, use the graphs to answer these questions. So find f of h of 2. So again, when it's written in parentheses like this, the first thing we're going to apply is h, and then we're going to apply function f. Now in this case, we don't have rules for the functions, we just have pictures. And so The question says, first come to graph H and look where x is equal to 2 and find the y value. Well, when x is equal to 2, y is equal to 2. So our y value, f of 2 would be equal to, h of 2 would be equal to 2. Now we're going to put that into function f. Again, we don't have a rule, we just have a picture. So we're going to come here to 2 on function f and see what the y value is. And so the y value there looks like it's about equal to 4. And so our final answer would be 4. So again, let's go through that again. We don't have rules, we only have pictures. We're going to start with function h, and we're going to put in a 2. So looking at function h, where x is equal to 2, we're asking ourselves, what's the y value? The y value would be 2. We take that, we put it into function f, so in other words, we look where x is equal to 2 and ask what's the y value, and the y value would be equal to 4. So our final answer would be equal to 4. Let's try one last example. For the last one, we're asked to do h dot f of 2. So remember, with the dots, we're going to apply function f first, and then function h. And we're going to do exactly the same thing. All right, so let's take a look. The only difference here is the order that we're doing it in. This time we're going to use function f first. So we're going to come here to function f, and where x is equal to 2, we already found out that the y value was 4. So when x is 2, the y value is 4. Now we're going to look at h. We're going to come here to x is equal to 4 and ask ourselves, what's the y value? Oh, the y value would be equal to 4. It goes through the point 4, comma 4. And so when x is 4, y is also 4. And so the value for h dot f of 2 is equal to 4. And again, this it reinforces that we have to be very careful of the order that we apply these functions in. So in the first case, we applied function h first. In the second case, we applied function f first. Coincidentally, the answers came out to be the same, but more often than not, they don't. So be careful about the order that you apply the functions. And that's the end of our problem set.